So today we're going to take a look at the derivatives of exponential functions. And so essentially, if we're taking the derivative with respect to x of a to the x, where a is just a positive real number, that's going to be equal to a to the x times the natural log of a. So essentially, you just scale a to the x up by a factor of the natural log of a. Keep in mind, the natural log of a is just going to be some number over here, right? Because a is just a number itself, and so when you take the natural log of a, then you're just going to get some other number. And so what we're going to do is we're going to actually take a look at a couple of examples of this, and we're going to come across a very interesting property when we take a look at the derivative of e to the x. So the derivative with respect to x of 2 to the x, essentially what we're going to do is we're just going to take 2 to the x and we're going to scale it up by a factor of the natural log of 2. The natural log of 2. And again, this right over here is just some number. We don't really need to simplify it or approximate it, and this would just be our final answer. So it's a very simple concept, the derivatives of exponential functions. You essentially just take the initial exponential function, you scale it up by a factor of the natural log of a, and that is your final answer. So the derivative with respect to x of 2 to the x is just 2 to the x times the natural log of 2 by our formula over here. The next one, the derivative with respect to x of 1/3 to the x. Again, same exact concept, we just take 1/3 to the x, and then we scale it by a factor of the natural log of 1/3. And because in this case, our a equals 1/3 in this particular case. And again, 1/3 to the x is just the same thing as 1/3 to x, so we can just write it as such. But yeah, this would be our final answer right over here, 1/3 to the x times the natural log of 1/3. And then when we come across the derivative with respect to x of e to the x, so let's just go ahead and use the same formula. So we're going to take e to the x, right over here, we'll just keep it the same, and then we'll scale it up by a factor of the natural log of e. But then what is the natural log of e? What power do we have to take e to get to e is another way to interpret that question. Well, we know that the natural log of e is just going to be equal to 1 because you need to take e to the first power, so e to the first power is going to be equal to e. And so essentially, the derivative with respect to x of e to the x, this is always going to be equal to e to the x because this just goes to 1, and as a result, regardless of how many derivatives we take, when we actually take a look at higher order derivatives, then we're going to come to find that you can take like the 100th derivative of e to the x. You can keep consistently taking the derivative and you'll always end up with e to the x. And so that is a very special property, definitely something important to memorize. This concept will appear very many times throughout all of your calculus journey. And essentially, that is all that we need to know about for exponential functions and their derivatives. So again, a very simple concept. All you need to think about is just scaling up by a factor of the natural log of a and just keeping your initial function the same. And that is essentially how you would take the derivative of any given exponential function. And always keep in mind that the derivative with respect to x of e to the x is just e to the x.